Hello, welcome to Chemistry Meal. Today on Chemistry Meal we are going to look at part 6 of electrochemistry, and in this part 6 we are looking at changing oxidation states of elements in chemical reactions. Subscribe to our YouTube channel and make sure that you follow us on Facebook at Mathematics and Science Meal. Alright, let's begin today's journey. You remember that in the last video we saw how we can find oxidation state of elements, and one of the application of oxidation state is in finding change in oxidation number. Now when some reactions occur, the oxidation state of elements can do what? Can change when some reactions occur. Not all reactions, because we have reactions that will not result to change in oxidation state of any of the elements that are involved in the reaction. So, but in some certain reactions, there is a change in in the oxidation state of of elements when certain reactions occur, and that means the oxidation state of the element will not be the same in the product and also on the reactant side. So we can say when some chemical reactions occur, the oxidation states of elements can change. This means, or this implies, that the oxidation state of the element on the reactant side will not be the same as its oxidation state on the product side. So when this happens, when we have this change in oxidation state, what it means is that the oxidation state of that particular element will not be the same as it is on the reactant side and also on the product side. So the oxidation state on the reactant side will not be the same as its oxidation state on the product side. So how then do we find this change in oxidation state? So to find change in oxidation state of an element in a given reaction, to find change in oxidation state, oxidation number, or state of an element in a given reaction, we do the following. We're going to do the following. First, find, or let's say we take note of the chemical reaction, take note of the chemical equation representing the chemical reaction. Then find the oxidation state of the element on the reactant side and also on the product side. And finally, then state the change in oxidation state. So then state the change in oxidation state. So when we want to find the change in oxidation state of a chemical reaction, the first thing we do is to take note of the chemical reaction representing the chemical equation representing the chemical reaction. Then we'll now find the oxidation state of the element on the reactant side, and also find the oxidation state of the element on the product side. Then finally, we can now decide to state the change in oxidation state. So let's quickly take an example to this effect. If I have example 1, we're now asked to find the change in oxidation state of carbon in the reaction below. Find the change in oxidation state of reaction of carbon in the reaction below. So what's the reaction now? We have carbon plus oxygen, carbon, which is a solid oxygen gas, giving us carbon, CO2, which is also a gas. So we want to find the change in oxidation state of carbon. So we're going to take these steps to achieve that. So let's go together. We have take note of the equation, giving me carbon, CO2, that's CO2 here. Alright. So we now find the oxidation state of the element on the reactant side. So the element here is carbon. That's the element we're talking about. So let's look at the reactant side. What's the oxidation state of carbon? Look at carbon. This is where carbon appeared on the reactant side. So here, that's carbon, just see. So the oxidation state of carbon on the reactant side is 0. Why? Carbon is in uncombined form. Now we say that when an element is free in a free state, or when an element is in uncombined form, that's the element did not combine with anything. It's not found inside what? Inside a compound, and that element is not in ionic state. The oxidation state of such element is what? 0. So carbon here is in non-combined form, is free. It's not found inside a compound. It's not in ionic state. So it's just existing as a molecule, as an atom. So when an element exists freely as a molecule or as an atom, the oxidation state of that element at that particular state is what? Is 0. That's why the oxidation state of carbon here is 0. So we go to the product side. Where can we find carbon in the product side? It's in CO2. That means we need to find the oxidation state of carbon here. So I say, let X be oxidation state of carbon. And we know already that the oxidation state of oxygen is minus what? Minus 2. Yeah. From the rules guiding what? Oxidation state. We say the oxidation state of oxygen is minus 2 in all compounds, except in peroxide, where its oxidation state is minus 1. So if we do this, we're going to have sum the oxidation state and equate to 0. You need to watch our videos on calculation of oxidation number to actually understand this. So X plus minus 2 times 2. Oxygen is minus 2, and we have 2 atoms of oxygen here, equals 0. So I have X minus 4 equals 0, which I can complete here as X is equal to 0 plus 4. X is what? Positive 4. So having found the oxidation state of carbon on the reactant side and also on the product side, we can comfortably state the change in oxidation state. And comfortably state that. So what is that change in oxidation state? So the change, or we can say oxidation state of carbon changed from 0 to plus 4 in the reaction. So the change in oxidation state of carbon here is 0 to what? To plus 4. So the oxidation state of carbon here is 0, and here is plus what? Is plus 4. Wow. So that's very simple. That's very simple. So let's quickly take a second question before we start talking about giving you takeaway questions. Yeah, because definitely we'll have some takeaway questions. Okay. So example 2. Let me put it this way. Without balancing the equation, below, state the change in the oxidation state of manganese. So what is the equation? MnO4 minus N plus 1 plus H plus I2 minus MnO2 plus H2O plus Fe in equal state. So we have this plus. So without balancing this equation, we are asked to state the change in oxidation state of what? Of manganese. Very simple. It's still the same principle. We need to find the oxidation state of manganese on the reactant side, find the oxidation state of manganese on the what? On the product side. So just very simple. So let's do that quickly. Let's do that quickly. Let's quickly do that. So we are going to have solution. We have MnO4 minus plus 1 plus H plus plus Fe 2 plus minus N2 plus H2 liquid plus Fe3 plus. So that's the equation. So what happens on the reactant side? So where can we find manganese on the reactant side? That's here. So we need to calculate it because the manganese here is not in free state, it's in combined form. So we can say let Y be the oxidation state, of manganese. Then the remaining element is oxygen. So we know that the oxidation state of oxygen is -2, right? So we can now begin our calculation. This is a radical. For radical, we sum the oxidation state and equate to the charge on the radical. So we have the oxidation state of manganese is Y plus that of oxygen -2, and we have 4 atoms of oxygen. So we write this is equal to -1 because that's the charge on the radical. If it is a compound, remember we equate to 0. Okay, so we have Y minus 8 equals -1. So Y becomes what? -1 plus 8. So Y will give us positive 7. So the oxidation state of manganese on the reactant side is +7. So what happens on the product side? On the product side, let's see the oxidation state of manganese. Where can we find manganese on the product? That's this. So manganese is in this form. Okay? Now, what is oxidation number? The charge an atom of an element appears to have when it is in ionic state. Now, this manganese is not free. Why? It is in ionic state. It's not in non-combined form. It is in ionic state, so it is not free. Remember that an element is only free if it exists as an atom or molecule separately. It's not inside a compound, and it is not in ionic state. And when an element is in ionic state, the charge on that element is its oxidation number. Therefore, the oxidation state of manganese on this product side is +2. So with this now, we can comfortably state the oxidation state of manganese, the change in oxidation state. So the change in oxidation state of manganese is from +7 here to +2. So that's actually a decrease. Now this change in oxidation state is very vital if we are going to identify reducing agents and the oxidizing agents in our further studies. So we will use the change in oxidation number to know the substance that is a reducing agent and the one that is oxidizing agent. So you see, in the case of manganese here, there is a decrease. But in the case of carbon, the first example, we have 0 to +4. So you see, the oxidation state of manganese decreased, but for carbon, the oxidation state increased. Now the substance whose oxidation state will decrease in the reaction is the oxidizing agent. While the substance which oxidation state will do increase in the course of the reaction will be the reducing agent. Yeah, that's how we can identify reducing agent and oxidizing agent in a given chemical reaction. And that will be one of the videos that we are going to see in the study of electrochemistry. So make sure that you follow us until we get there, because most times in external examinations they used to ask this question: which of these substances is the reducing agent? Which substance is acting as the reducing agent in this reaction? So we are going to meet that. All right, we will not leave you empty-handed. That's why there is need for us to take some takeaway questions. So get ready for that. Yeah, get ready for takeaway question. I know you are happy now, because anytime people hear takeaway, they are always happy. Yes, so I know you are very happy hearing takeaway. So let's have some takeaway questions. Takeaway questions. Okay. Number 1, state the change in oxidation state of bromine in the reaction below. So we have sodium bromide reacting with chlorine, giving me sodium chloride and bromine. So if we balance this, we have this nucleus one, the gaseous one, the nucleus one, and this is a liquid at room temperature. So we have that. Then question number 2, without balancing the equation below, state the change in the oxidation states of A, chromium, B, carbon. So let's state that. So what is the equation? The equation is CR2072 minus nucleus 1 plus H plus C2O4 2 minus, let's take the nucleus 1 to give us CR3 plus H2O plus CO2. So without balancing the equation, state the change in oxidation states of chromium and also carbon. So we are going to get the change in oxidation state of 2 different elements. After dealing with chromium, then you deal with what? With carbon. That's how far we can go in this video. In the next part of our electrochemistry, we are going to solve the equation on the change in oxidation states of elements. Then after solving the equation, we'll now move on to the next part, where we're going to consider reducing agent and oxidizing agent, and then we look at redox reaction, and that will conclude the aspect of oxidation. But that's not the end of electrochemistry, because we still have other aspects of electrochemistry to look at. When we finish with redox reaction, electrolysis is waiting for us. Even if we finish electrolysis, electrode potential is still part of electrochemistry. And then finally, we are going to conclude it with the concept of electrochemical cell. So you see, you cannot afford to miss any of these videos in electrochemistry. And you know that this topic is very important, very, very important in chemistry, because most exam bodies, they usually set questions from this particular topic. So make sure that you follow us to the end of electrochemistry, and make sure you subscribe so that anytime we upload a video on electrochemistry, you will know about it and you can easily access the video. Thank you for watching our video till now. I'm still your friend, I'm your brother, and also your lovely and handsome tutor. Well, in case you don't know I'm handsome, if you don't believe me, that's your business. Don't mind me. I'm still your friend and your tutor, Engineer I. Okay, bye.